In this video, we will solve a question on production function. This question was asked by a person on Telegram channel of Economaths. The question is, consider the production function Q is equal to k to the power zero point 0.5 plus L to the power zero point 0.5 whole square, where K and L are the units of capital and labor and Q denotes the output. We have to mention what is the name of this type of production function, what is the elasticity of substitution for this production function, and does this production function exhibit increasing, decreasing, or constant returns to scale. Okay, so let us do it one by one. So we are being given Q is equal to k to the power 0.5 plus L to the power 0.5 whole square. Okay, now this type of production function, what we call the constant elasticity substitution production function. Okay, CES production function. Okay, here these exponents 0.5 and 0.5, these are the distribution parameters. Okay, and this 2 is called the substitution parameter. So the first thing is, it is the CES production function. Next thing is, we need to find out the elasticity of substitution of this production function. Okay, now how do we find elasticity of substitution? The formula is elasticity of substitution is equal to, and let me write it here, it is simply the change in capital labor ratio with respect to change in the input price ratios, that is price of labor upon price of capital, into this input ratio, the price ratio PL upon PK divided by capital labor ratio. This is the formula for elasticity of substitution. Okay, about constant elasticity substitution production function, I have explained it in detail in other videos. You can check out that very videos in the playlist. Okay, now we need to find out the elasticity of substitution. Okay, now to find the elasticity of substitution, what we need to do, we need to maximize this production function. Okay, we want to maximize, or we write first order condition for maximization requires that the marginal rate of technical substitution between labor and capital should be equal to the price of labor upon price of capital. MRTS simply means marginal product of labor upon marginal product of capital should be equal to price of labor upon price of capital. Okay, now what is MPL? MPL is simply the partial derivative of production function with respect to, let me write it here, I don't have the space here. Okay, or let me write it here, dq upon dl means the marginal product of labor, and dq upon dk means marginal product of labor should be, capital should be equal to the ratio of prices, the input prices, that's price of labor upon price of capital. Now dq upon dl means the partial derivative of this production function with respect to labor. Okay, if I take partial derivative of this production function with respect to labor, what will I get? So first thing is, we apply the power function rule. So exponent becomes coefficient, so we have twice k raised power 0.5 plus L raised power 0.5. Okay, and exponent is subtracted by 1, so 2 minus 1 is 1, and then we apply chain rule. Since we are taking derivative with respect to L, so we multiply it with the derivative of L, which is in the parentheses. So derivative of L to the power 0.5 will be 0.5. Again, exponent becomes coefficient, then we have L, and exponent is subtracted by 1, it becomes minus 0.5. Okay, I don't have the space to explain it more here. Symmetrically, the derivative of production function with respect to capital will give us MPK. Okay, so simple thing. This time again we apply this power function rule. So we have k to the power 0.5 plus L to the power 0.5. Okay, then we apply chain rule. So we multiply it with the derivative of k, which is in the parenthesis. So derivative of k to the power 0.5 will be 0.5 will become exponent k raised power exponent will be subtracted by 1, that is 0.5 minus 1 is minus 0.5. It should be equal to the ratio of the prices, that's price of labor upon price of capital. Okay, here we can do some cancellation. In fact, we can do lot of cancellation here. 2 and 2 gets cancelled, this gets cancelled, 0.5 gets cancelled with this. So we are left with L to the power 0.5 divided by K to the power 0.5. So it becomes, if I transpose these, so it will become K to the power 0.5, L to the power 0.5. I have transposed denominator, denominator term to numerator, exponent sign gets changed, and similarly I have transposed the numerator to denominator. Okay, so it should be equal to price of labor upon price of capital. Okay, so here we can write it in this fashion: k upon L raised power 0.5 is equal to PL upon PK, which implies KL can be written as 1 upon 2 as exponent 0.5 can be written in this fashion, PL upon PK. Okay, I am explaining how will I write it. So K upon L will be equal to, if I transpose exponent, it will become, let us see here. So it will get reciprocated, it will become the exponent, so it becomes 2 here. 1 upon 2 will become 2. So for that, I can now write K upon L is equal to PL upon PK square. Okay, now I can substitute this, what I call, so we first thing was to find out this capital labor ratio. Okay, since the formula is this, so we take the derivative of capital labor ratio with respect to the input price ratios. That means del K upon L with respect to del PL upon PK. Okay, so simply this is a function, capital labor ratio is a function of input price ratios. We take the derivative of this function with respect to input price ratio. Again, so taking derivative of this input price ratio, so 2 becomes, exponent, exponent becomes coefficient, so we have 2 PL upon PK, and exponent is subtracted by 1, so it becomes 1 here. Now what will be the elasticity of substitution for, okay, so elasticity of substitution will be equal to, and we have here, that is this derivative, and we calculated, it came out to be this stuff here. Let's write it here, okay, to save the space. So dk upon dl, so this elasticity of substitution depends upon this derivative, so we got it as twice price of labor upon price of capital, okay, into, then we have PL upon PK, so PL upon PK divided by K upon L, and K upon L we got it equal to PL upon PK square, PL upon PK square. Okay, so this can be written as twice, these are same, we can add up their exponents, so this becomes PL upon PK square divided by PL upon PK square. Okay, so this gets cancelled, we get 2 as the elasticity of substitution. Okay, so let me write it here. This is our elasticity of substitution, comes out to be this, that is, we have the constant elasticity of substitution, that means elasticity of substitution is 2 in this constant elasticity substitution production function. Okay, now the third part tells us, does this production function exhibit increasing, decreasing, or constant returns to scale? Okay, so to see whether it exhibits some kind of scale, first we need to find out whether it is homogeneous, of what degree of homogeneity it is it. Okay, we say, and let me write it here, A function is said to be homogeneous of degree n if a function is multiplied by, let us say, lambda x, lambda y, and if we get it in this fashion, that is lambda raised power n f of xy, we say this function is homogeneous of degree n. Okay, if we are able, simple thing, if we multiply each input by a factor lambda, and if this lambda comes out to be, if we are able to take out this lambda in each of the terms, then we say this function is homogeneous. Okay, now in our case, what is our production function? Okay, for that let me rub this out. I don't want to mess it with other stuff. And let me write, a function is said to be homogeneous if f of lambda, let us say in this case we have lambda k lambda l is equal to lambda raised power n f of kl. I will explain it here. So what is our production function? We have, let us write q is a function of, here it is the function of capital N labor, which is equal to k to the power 0.5 plus l to the power 0.5 square. Okay, now let us say if each input is multiplied, okay, by a factor, let us say by lambda, then what will happen? So our f of lambda k lambda l will become, okay, we are multiplying each factor with lambda, so it will become lambda k raised power 0.5 plus lambda l raised power 0.5 whole square. Okay, now here we can do one thing. If I write it in this fashion, lambda raised power 0.5 k to the power 0.5 plus lambda raised power 0.5 l to the power 0.5 square. Okay, also we can write it in this fashion. Let us take lambda raised power 0.5 common, lambda raised power 0.5 common, so we are left with k to the power 0.5 plus l to the power 0.5, okay, whole square. And this can be written in this fashion, which is equal to let's just expand it now. So I can write lambda raised power 0.5 whole square, then I have this k to the power 0.5 plus l to the power 0.5 whole square. So 0.5 into 2, it becomes 1. So we get here lambda k to the power 0.5 plus l to the power 0.5 square. Okay, which is equal to lambda, na laguniyat let the magli, lambda raised power 1 I can write, no problem. So what is this? K to the power 0.5 plus l to the power 0.5 square. So this is our initial production function, that is f of kl. Okay, that means we have f of lambda l lambda k is equal to, we got it equal to lambda was taken out and we got the original function kl, and here the exponent is 1. Okay, when each input factor was multiplied by lambda, okay, our output also get multiplied by that very lambda. Since the exponent of lambda is 1, we say this production function exhibits constant returns to scale. Okay, if the exponent of lambda was less than 1, then we would have decreasing returns to scale. If the exponent of the lambda was, let me write it here. If the exponent, okay, if the exponent of lambda was equal to 1, we got constant returns to scale. If it was less than 1, we will get decreasing returns to scale. If it is greater than 1, we will get increasing returns to scale. Since we got the exponent of lambda is 1, so this production function exhibits constant return to scale. Okay, I hope I make myself clear in this video. To know more about the CES production function and how do we find out the elasticity of substitution, I have explained it all in a very detailed video. You can check that video out in the playlist of this channel. Okay, have a nice day.